This is example 3 of the compounded interest and continuously compounded interest lab. We have the following problem. Money is deposited into an account that pays 3.2% annual interest compounded continuously. If the initial deposit is $8,000, find the time it takes for the account to double in value. So first you're going to notice that it says compounded continuously. This tells us our formula right here. This is the continuously compounded interest formula. A equals P times E to the RT, where A is the amount accumulated after T years, P is the principal or starting amount, R is the interest rate in decimal form, and T is the time in years. So we notice that we have money that's deposited into an account that pays 3.2% annual interest. So this right here is our R. If the initial deposit is $8,000, so our initial deposit, that's our P or our starting amount. And we want to find the time, so we're going to be looking for T. It takes for the account to double in value. So double in value, this double in value is going to be our A. So if we take a look at the formula one more time, A is the amount accumulated after T years, P is the principal or starting amount, R is the interest rate, T is the time in years. We're going to put it in its actual format. So we have our A is equal to PE to the RT. So our A is where the account is going to double in value. Well, our principal amount was $8,000. So doubling $8,000, that's going to be $1,600. Our P is 8,000 times E. Our R is our annual interest rate, or 3.2%, but this has to be in decimal format, so we're going to move that decimal over twice, so it's going to be 0.032 times T, our time in years. So now we have this problem where we need to solve for T. So we're going to divide each side by 8,000. 1,600 divided by 8,000 is going to simply be 2. So we have 2 equals E to the 0.032 times T. And now we need to bring down this exponent. And since our base is E, we're going to take the natural log of both sides so that we can take down this exponent. So we have ln of 2 is equal to ln of E to the 0.032 times T. And there's a rule that if you have an exponent, you can bring over to the front. And then ln of E is simply just 1. It essentially cancels out. So in essence, we have ln of 2 is equal to 0.032 times T. And we'll just divide each side by 0.032. So we have ln of 2 divided by 0.032 is equal to T. And once we put that into a calculator, we find that T is about 21.7 years.